So let's talk about acceleration, and let's start with the graph because I think the graph will really help. Acceleration. So what I want to do here is that I want to continue to plot position versus time, but now include changing velocity. And it turns out that the only changing velocity that we're going to look at here is that we're going to focus only on changing speed, constant direction. We do not have the ability to talk about turning acceleration because that's actually turns out to be more complicated, but we will get to that. And what we're going to show here is that when I talk about this changing speed, that means we're going to be talking about speeding up, and we're also going to be talking about slowing down. We're not going to be talking about turning. So picture-wise, I'm going to continue like up here. So if we go up here, we saw that we had cases, right? We had a case of stationary object, moving object with constant velocity. So now what I'm going to do here is that I'm going to add a third case because it's all connected. So then this will then be case 3. We're going to be talking about changing velocity. So what do I mean here? So let's look at this thing graphically. So if I am speeding up, what does that really mean? Speeding up really tells us something like this. It says that if I have my dots are getting farther and farther apart. Let's say that I start from rest here. So then what I'm going to see here is that I'm going to go to V1. Then I'm going to go to V2. And then I'm going to go to V3. And I think I'm going to stop right there. So the thing that I gotta pay attention to is my intervals. Look at this little tiny interval right there. And then look at this next interval. And then look at this next interval. We can see here that the first interval right here is delta x1. We could see that this interval right here, I'm going to call delta x3. So because the flashes are the same, right? They should be the same size. What I'm seeing here is that I'm seeing that my changes in the x's, delta x's, are getting larger and larger and larger. So what does that mean here? This implies that this is less steep. This implies that this is steeper. Okay? So we want to plot these changing velocities, right? So when I start to look at this thing, this is telling me here is that plotting changing velocities implies changing slopes. So let's draw this out. So if I look at my curve, what am I seeing here? Okay, so here I go. So this is x of t. So now what happens? Look at what we started at. This is my 0. This is my 1, 2, 3. You could see that at point 0, it's at rest. There's no arrow there. So look at this. So here I go. I'm going to go from here to here. And look at what happens. That is a horizontal line right here. Right? That's a horizontal line. That tells me right away that delta x is equal to 0. So it's at rest. Now, my first little delta x tells me that it changed slope. So then I'm going to say that this guy's going to go like this now. And look at this. You could see here that there's a little delta x1. There's a slight slope. Because there's a slight slope, that slope right there tells me that has to be speed 1. Now, when I go to the next dot, you could see that I have a bigger change in delta x. So if I look at this, you can see here that from here to here, that's delta x2. That slope is bigger. So therefore, that's associated with a steeper slope. And then if I continue on, and I get to a steeper slope right here, you can see here that that is even steeper. So when I look at this guy, that's an even bigger slope change. So therefore, that speed is associated with a higher speed. So now, if I was to, in physics, there is no discontinuities in regular motion. And so what we find here is that if we smooth this out a little bit, here's what we see. If you are speeding up, it is a smooth transition. So therefore, it then moves like this. So a curve that is curving like this shows you that you are speeding up. Why are you speeding up? Because look at the slopes. You can see that the slope here is flat. That immediately tells you that that is 0. But then if I look at the next slope, you can see here that that is not as steep. But if I come over here, you could see that this is a steeper slope. So this is less steep, and this is steeper. So it's the steepness of the slope that tells you about the speed. That's how you graphically look at this thing. Now, we can go back and we can look at the same thing here. Let's talk about slowing down. So let's do the exact same thing, but let's move it over here to the right. So here I go. So let me try not to overlap these guys. So this is going to be slowing down. So it's a one-to-one correspondence. So here I go. The same thing. So if I do that, I'm going to say that this is my 0 point. Maybe I should start right here. And what I'm going to do here is that I'm going to slow down. So then I'm going to go 3, 2, 1. So if I look at my arrows then, this is longer, shorter, even shorter, and I could even, continue to move on and make it even shorter. But let's not do that. Let's say that we just only focus on 3. So in this case, what you're seeing, you know what? I think I'm going to put one without an arrow. So this will then be 1, 2, 3. And again, what do we see? Look at my intervals. My intervals are long, getting shorter and shorter. So this tells me here, again, from the same type of thing as we did before, this tells me that this is delta x1. This tells me that this is delta x2. This tells me that this is delta x3. Okay. Now, if I do that, then if I come and I look at these guys, you can see that this guy right here clearly tells me it's steeper. This guy is telling me that it's less steep. So then if I come in and I plot this as we said before, right? As we said over here, plotting changing velocity implies changing slopes. So here we go. So now if I come in and I do the exact same thing as over here, what do I see here? Well, I see here that, oh, I did not draw this over here. So this should be V1. This should be V2. This should be V3. So what do I see here? V1 has a very steep slope. So then I'm going to come over here and I'm going to say, okay, let's say that it comes all the way right up to here. So when I look at this thing, what I'm seeing here is that this guy right here is looking like this. So you can see that this point right here is my point 1. And if I look at this guy right here. That is a big distance delta x1, which then means that I have a steep slope right there. And then the very next one means that I have to have a less steep of a slope. So then if I come over here and let's say that I do something like this, you could then see that this difference right here tells me that that is not as big as delta x1. So at this point, we then say here that the speed has to be smaller. And then if I continue along this line, you'll see here is that this will be my point 3. And you can see here that there's this little tiny delta 3 right here. And then, oh, did I miss a point here? This is 0. So that's 0, 1, 2, 3. Yeah, maybe I should have added another arrow. Oh, I should have added another arrow right here. And then added a point 4 where I actually stop. So if I do that, then right here, you'll see here at point 3, and this is point 4, note that this guy is flat. And because that guy is flat right there, I'm going to say that that tells me that delta x4 is 0, showing you that I have a slope like that. So if I now put this all together and say that we don't have jerky curves like that in nature, then my curve is then going to look like this. And so again, if I look at my slopes as I did before. This slope right here, maybe I should draw it in a different color. You could see that it's very steep. And then as the curve goes along, you could see that the slopes are changing. And then again at the top, you could see that the slope is flat. So this tells me that V4 is equal to 0. And then this guy, because it's steep, that's going to be V1. And let's say this guy is going to be V2. That's what I mean by these slopes right here.